Hi, and in this video we're going to create a simple character controller inside Unity using the input system. This is what we're going to make. So we're going to make a player which can just simply move left and right using the arrow keys or the A and D keys, and you can press spacebar to jump or the W key to jump. So that's what we're going to make. We'll be handling input by using the input actions asset, and we'll be using the player input component for the input. So let's get into the video. So I just quickly wanted to mention that I initially wanted to make a much smaller video, about like 5 to 10 minutes long, and I don't mind making such tutorials, but for this particular one I just wanted to make things clear as much as possible, and I wanted things to take enough time so that I don't lose important bits of detail. And I hope you don't mind that this video is particularly long, because I don't want to skip any information unless they are just very straightforward stuff. And this video is about performing movement in 2D using the input system. So if you are someone who have used input system before, you can actually skip over the installation bits and the part where I explain the input system. And you can do that by checking out the YouTube slider, and you can see that it's divided into parts. Or you can open up the description of this video and then you will see that it's divided into chapters. And you can skip chapters that you already have some idea of. Also, if you don't understand what I'm saying, or if I'm not clear enough, you can always enable closed captions, which is a button on top right. In mobiles, I don't know where it is. On PC, it's probably bottom right, but it's a button called CC. If you press on it, you can actually view subtitles in English. So yeah, back to the video. Alright, I have a very simple scene setup. As you can see, this is just a plain 2D level. If I go into 3D mode, you can see that this is just simple sprites arranged one in front of the other to just simply create a parallax effect. I have a simple directional light and an environment which contains the entire environment, which is divided into 3 individual layers. We have platforms, which is this. We have background layer 1, which is the first layer behind the player, and we have background layer 2, which is the furthermost layer in the scene. A thing to mention is that I have created 3 layers inside Unity. I have created a player layer, platforms layer, and a background layer. So the player has been assigned a layer called player. The platforms have been assigned a layer platforms, and you can press yes to change all these children directly, or you can select them all using shift and then change the layer. But I like to do things this way. This is much more neater. And the background layers are simply put in a layer called background because they don't have any colliders and stuff. I just want them to move out of the way. And I also have a main camera, which is a prefab, which has a script called follow target. What this simply does is just follows a particular target, and I've assigned the player as the target. So if I play the game, as of now the player cannot move, but if I select the player and then move it, you can see that the camera moves along with it. And if you are interested in a camera follow script like this, I'll have a video up soon, which I will link it in the top right. Alright, quickly looking at the player, it's a prefab, and I have a simple empty game object which is parented to the sprite. The sprite is created with the help of sprite shape renderer and a sprite shape controller, which just simply allows me to change the shape inside of Unity. This is useful especially while prototyping, but if you are making a final game, I highly recommend creating actual sprites over a controller like this. But this is a great way to get started in prototyping. The character I had in mind is a blob, so I used the shape controller, and it makes sense for me. You can obviously use a box if you want to. So yeah, enough talk, let's get right into it. The first thing you need to do is install the input system package. If you don't know how to install the input system or in package in Unity, I have a video on it. You can just check out the input system playlist that I've linked before, or you can find it in the description of this video. So you go to Window and then Package Manager and then click on Unity Registry, and then you need to scroll down to where it says Input System and then make sure you hit Install. I already have it installed, so I can only remove it. Yeah, this is a quick way to install it. So once you install it, it will give us a pop-up like this, and it just requests permission to enable Input System backends or not. And you simply hit yes, and then editor will restart, and then you're good to go. But I highly recommend checking out the installation video because it teaches us how to use these samples and how to learn from them. Cool. So just make sure that you have a tick mark over here to make sure that the input system is installed. And the next thing is you have to go to project settings and then just go to the player tab and the other settings and make sure that active input handling is either set to both or set to input system package. So let's get into business. So if you watched the input system theory video of mine, again the link is in the description, you'll know that the input system introduces an asset which you can use to manage controls inside your game, and that is called the input actions asset. So we need to create that first. So let's create a folder called input, and inside that I'll right click, create, and then choose input actions over here on the most bottom, and it says new controls, but I'm going to name it player controls, and it just creates a file or an asset in the project. So if you double click, it opens up a window like this. I'm just going to drag it onto here, and you can see that there are 3 columns. So what is this? So the input actions asset is simply an asset which controls everything related to your input in one place. If you didn't have this, you'd have to create a manual class which is just a ton of work, and input reminding is a total pain in the ass. So using the input system is always a plus in my book. You could get away with simply using the input actions asset, and you don't even need to know that much when it comes to C#. You can just get away with basic C# and then move on. So we have 3 columns here: an action map, an action, and properties. So imagine the controls menu inside a game. So you have 2 columns, right? We have an action and a binding. Let's take an example. So you have an action called jump, and to that particular action you have a binding called space. So what it essentially means is that if you press spacebar or whatever key that is being binded to this particular action, this action will be performed. Or in other words, in order to perform this particular action, you have to press whatever binding is on the right. So that's exactly how this particular thing works, but in a way better. Essentially what we do is we simply create a bunch of actions inside this particular asset and then play around with it and do whatever we have to do. But this introduces another thing called action maps, and an action map is simply a collection of actions or relatable actions grouped together. So if you have no idea what I'm talking about, just bear with me for a second. So let's just create an action map to see what happens. So if I click this plus, you can see that it created a new action map, and along with that it created a new action. You can see that there are properties to this action. You can click on it and press F2 to name it, and I'll call this movement because we need to create a set of actions that are related to player movement. The advantage of using action maps is that you can create multiple action maps. So you can have one for movement, and you can have one for shooting, and you can have another one called driving. So by default, movement will be activated while shooting and driving will be deactivated. But when you pick up a gun, you can enable shooting and you have movement alongside as well. But when you're inside a car, you have to disable shooting and movement and enable driving. So you can have set of controls for a particular action map. So you can enable and disable action map whenever you need to, and this makes things a lot easier for us. And then we have an action. So we have created an action called new action, and if you open it up, it says no binding. So this particular column decides which binding will be assigned to which action. So you have an action called new action. I'll just rename this to, let's say, jump. Alright, and then to this action we haven't assigned a binding. But if you look at the properties, you can see that the action type is a button, which means that it works exactly like a key press. So if you press this particular binding, the thing will work, which also means that we can add as many bindings as we want. So for example, we can create a spacebar binding and also a W key binding which we want. But yeah, that's essentially how it works, and these properties can be changed. I will explain as I go. If you're starting out, you don't have to worry too much about interactions and processes. You just have to look into the binding and then the action type. But I'll just delete everything and then start fresh. Alright, so the first thing that you should do is not create an action map, but instead create a control scheme. and a control scheme decides the blueprints for the controls for a particular device or a group of device. So let's just create one to get it out of the way. So you can see here there are no control schemes as of now. If you click on it, you can add a control scheme and you can create a name. So I will say keyboard and mouse, but that alone won't be necessary because you need to add a keyboard and a mouse. If you click plus, you can select a keyboard. If you click plus again, you can select a mouse and you can click on mouse and then you need to hit save. So right now we have created a control scheme called keyboard and mouse. We can create another control scheme for, let's say, gamepad, and then select gamepad and save. So you can edit a control scheme by clicking on edit control scheme, and then you can simply set the gamepad to optional, and we have keyboard and mouse which is set to required. Cool. So let's just save it by clicking on save as it. And as you can see, since we created a control scheme, this particular option got highlighted and you can select keyboard and mouse if you want to, and you can filter controls based on particular device. Alright, so we have created a keyboard and mouse control scheme and we'll just create an action map. So we only need one action map for this particular tutorial, so I'll just call it movement. And for the action, let's create an action called jump. So let's get into the action properties. So we have an action type. If you click on it, there are three types of action types. You have a thing called value, and using an action of type value returns an input value. And by that, I mean it could be something like a boolean, it could be something like a float value or a vector too. If you choose value, you can see that there is a control type and you have lots of control type to choose from. By default, it's set to button, which is default for a boolean. Since a button works like true and false, you can return a true and a false if you want to. A useful thing would be axis, which returns a float value between -1 and +1. You can also return a vector 2, which could be useful for WASD movement, which could be useful for top-down video games. You can also return a vector 3. You can return a quaternion. You can return a key, or whatever you want. I'll set it back to button. And you also have pass-through, which is useful when you have multiple control schemes. If you're a beginner to the input system, just understand that pass-through helps in using multiple devices at the same time. So if you have a controller and if you have a keyboard, you can use the controller anytime and it will still work. If you set it to value, it will use only one particular device. So it will completely ignore the controller if it is set to value. So pass-through is actually nice. There are other importance to it. You can read more by hovering over the action type here. But the thing is, don't stress too much about it. So if you're quite advanced into the input system, using pass-through will have some advantages when you actually generate C# classes and work with Unity events directly through code. But if you're someone who's just trying to get things done, just don't worry over it. Alright? And I personally don't like overstraining myself. So for this jump, we'll use a button because it makes sense, right? If you press the button for jump, it jumps. So that's what button does. Unlike value, it does not return a boolean, but it's just simply triggers something whenever this button is pressed. That's it. Using value and a button could be useful sometimes, but essentially button is better in my opinion. So once you created an action, you can create a binding over here, and right now it's set to no binding. So let's set a binding. So if you click on the path here, you can type space to select space, and it automatically names it based on the path. So if you press space, an action called jump will be triggered. Right now it doesn't do anything because we have to write the code for it. But yeah, that's essentially how things work. Let's create another action. So this is pretty straightforward because the action type is button and it's not too complicated. Let's create another action as well. So we'll create a horizontal movement because this is a platformer game and we need only left and right. And in this case, we need a particular value. In the input manager, we used to do get axis horizontal, which returns a float value from -1 to 1. And we're doing the same thing here. So instead of a button, we need a value, or in this case, we'll use pass-through. And for control type, we'll choose an axis because that is the value that we need. We need a value between -1 and 1. Don't worry too much about the initial state check. I'm going to disable this because it doesn't really matter right now. And I'll be honest, I have no idea what initial state check does. If you set this to value, this will be true, which means that it performs a state check whenever an input update is being happened. It might seem complicated, but it doesn't really matter. If you know what this checkbox is useful for, please do comment down below so that I can pin them. And for the horizontal binding, we have a path. So what can we do here? We can't use a binding like this for a particular axis. So I'm going to delete this. Instead, we're going to click on this, right click, and then you can add a positive or negative binding. And what this does is it simply creates a 1D axis for you. So I'm just going to call this A and D, as in A and D from the keyboard. And for the negative, I'm going to choose the path called A. Another way to do this would be to click on this listen button and then you simply press A on the keyboard like this and it will show up. So if you go to positive, go to path, listen, and then press D on the keyboard. So make sure that A is set to negative and D is set to positive. You can also click on this and then hit Ctrl D to duplicate and then rename this to arrow keys, and you can select the left arrow and the right arrow for the positive and negative controls. So now you have two bindings to a single action, which means that if A or D is pressed or if the arrow keys are pressed, you can trigger the horizontal movement action. And now we have set up a very basic action map called movement. So I'll just simply save the asset to continue with our coding. And let's start to make things work. So I'll go back to the scene. Firstly, I'll create a player controller script. So I'll go to my player folder, right click, C# script, I'll call this player controller, and I'll double click to open it in Visual Studio. So the best thing about input system is you don't have to necessarily work with start and update. In the input manager, we used to do everything inside update or fixed update and things would work. But the cool thing about the input system is that it uses unit events, which means that we have relatively less work compared to that of before. We don't have too much update checks. We don't have any unnecessary string operations to be performed. Like when we had input.getAccess horizontal, it's a string operation. We don't have stuff like that, and it just works pretty easily. Alright, so what we're going to do is we're going to use a component. I'll just be straightforward. This is not the only way to do it, but this is by far the easiest way to do things. And that is to use the player input component. So I'll go back to Unity, I'll select the player, and you can see that the player already has a box collider and a rigid body 2D attached to it. I've also enabled freeze rotation Z. So I'll just open the prefab and then add a component called player input. There is a player input manager which would be useful for multiplayer, split screen stuff, but we're going to focus on player input. Alright, and this is it. It is asking for an input actions asset, which we'll click on this dot here and then select the player controls which we have made. And it asks for a default scheme, and you can select the keyboard and mouse. It's good to enable auto switch, which means that it switches devices when a new device is automatically plugged in. We have a default map, which we have movement, which is the only map available. For UI input module, it's useful for when you have UI. You have a camera, which we don't need right now because this is useful only for split screen projects. And then you have a thing called behavior. Now behavior, there are 4 types of behavior. By default, it's set to send messages, which is not the best way to do it, but it works. It's quite optimized. It works, but it's not the best way of doing things. But that is how we're going to do this today because it works. So you have send messages and broadcast messages, which are not the best way of doing things, but that's exactly how we're going to do in this tutorial because it makes things a lot easy. And for quickly prototyping things, I think using send messages is a good idea. The way you should be doing it is either using invoke Unity events, which lets you create Unity events and then add it, but this may not be beginner friendly. You need to have a general idea of how callback context works and then how Unity events work. You could relate it to how Unity UI works because the UI uses Unity events as well. You can also invoke C# events, which has a much higher learning curve compared to the other ones. When what send messages does is it scans through all mono behaviors or components inside the particular game object and then assigns a function to a particular action. And what broadcast messages does is it does the same thing as send messages but it also scans the children's mono behaviors and then adds function to particular actions, which could be useful as well. These are not the most optimized way of doing things. I highly recommend using invoke unity events. If you're starting out, just work with send messages. It works. You don't have to stress yourself trying to speed things up right away. You could just get away with using send messages for now and then slowly optimize your way through using unity events. And that's pretty much it. And the next thing is we're going to drag and drop the player controller. Let's just work on the jumping. So in order to jump, we need a rigid body 2D, and I'll just call it RB2D. And I'm going to use lambda operations to just simply, git component rigid body 2D. And this is equivalent as just getting the rigid body 2D at start. You can just shorten it like this. We'll also create a serialized field, float. Let's call it jump force. And now, the only thing that we have to do is to link a function inside our script to this particular action called jump. And that's very easy to do because we have sent messages or broadcast messages selected on the behavior of the player input. So what we do is simply create a private or a public function, it's your choice. But I'm going to create a private function because it's more secure. So private void, and all you have to focus on is on the name of the function. So you write on followed by the name of the action, which is jump. So we have on jump, and we're good to go. And that's it. That's the only thing that you have to do. And what we'll simply do is we'll firstly say debug.log jumping. I will save this and go back to Unity. And if I have the console up and play the game, if I press spacebar, you can see that it shows us jumping. So that's it. So you have full control of what bindings that you should use inside this asset, which means that if you want to change this inside your game, you only have to get a reference to this particular asset and then change it inside the asset, which is far more easier than having to create a custom input class and do all the rebinding manually through code. And this just makes your life a lot easier. Trust me, you would want to use this in all of your projects, especially on commercial ones. So instead of debug.log, let's just say rigid body 2D dot, instead of add force, what we're going to do is velocity. I don't like using add force for jumping because it is realistic. And if you're making a game like Mario, the jump or anything in it is not realistic. If we let everything into the hands of the physics engine, it's going to do things properly, which means that we have very little control of how we want to do things, which is one of the reasons why I recommend using velocity, which is not the recommended way, but it gives you full manual control of how you want to jump. For example, you can clamp the velocity whenever you want. So you could make it that it doesn't exceed a particular speed. So rigid body 2D.velocity, and since it's jumping, we don't want to change the x value, so we'll say plus equals vector2 dot up, because we need the y-axis. We'll multiply it by the jump force, and that's it. So if you go back and if you click the player, so you'll have a jump force. I'm going to set a value of 3, and if you jump, 3 is not enough, so I'll go back and change this to 6, maybe 8, and you can see we have a lot of problems. Firstly, this is slow, and secondly, you can just jump as high as you want. So let's fix that quickly. If you want to jump faster or fall down faster, the way to do it, the quickest way to do it, is to increase the gravity scale and increase the jump force simultaneously, and find a value in between that makes it smooth. So I've done my testing, and I am setting a value of 17 for gravity scale, and jump force is going to be 40. So if I play the game now, you can see that the player jumps and falls down quickly. This is quicker, this is quirky, and this is quite responsive for the player compared to the other one. So that part is done, but let's fix the double jumping. So the thing is, we should only jump when we are grounded. So that's exactly what we're going to do. So we're going to test whether the player is grounded or not. So we'll create a simple bool called isGrounded. For this, we'll have to use the update function. We'll just create a function called check for ground or something like that. I'll click on this, Alt Enter, generate method, and inside this, what I'm simply going to do is set isGrounded equals physics 2D dot boxcast. The reason why we are using a boxcast over a raycast is because raycast works from a point. So if you are on the edge like this, you can see that the collider is still there, but if you raycast it from here, it is going to treat it as if it is not grounded. Alright, you cannot use spearcast as well because spearcast works exactly like the spear over here. So if you are here, you can see that this particular spear overlaps the collider for the platform, which means that this, even though it's in the air, this will treat it as if it is grounded. So you can't use spearcast as well. Boxcast can be used as long as you have a very tiny breadth for the rectangle or box. So we're going to use boxcast, and boxcast uses a position which is going to be transform.position. And the reason why I'm using transform.position is because I've created an empty game object. If you open the prefab, you can see that the player sprite is lifted by 0.6 so that the empty game object rests at the feet of the sprite. So we don't actually need to use another transform to get this feet position. Instead, we could use transform.position directly. So you can say transform.position for the center of the box, and it asks us for the size, which will be a new vector2, and we need two variables, a serialized field, vector2, we're going to call this ground check dimensions, and instead of new vector2 over here, we'll say ground check dimensions directly, and we have an angle which would be 0 because we want it to be perfectly straight. An angle would just rotate the box cast to a particular angle, and you have a direction which would be negative transform dot up. You also need to specify a distance. Alright, you need to use the distance, otherwise it will treat it as infinity. You need to have a minimum distance, so I'm going to say 0.1f, and you will need a filter for the layer masks so that it only takes colliders of a particular layer. We're going to say serialized field, layer mask, platform layer, and we're just going to cast it for the platform layer only. So that's what check for ground does, and we'll only jump if we are grounded. So right now we don't have a value. So we have a value of 0 and 0. I'll choose the platform layer to be the platforms, but how do we check what dimensions do we use? So we'll use the gizmos for this. So I'll just create a function. We'll just type on gizmos. So we'll use on gizmo selected. I'm going to simply draw a gizmo by using gizmos dot draw via cube, and we're just going to draw a cube of a particular size. So we're going to say transform.position, and then we're going to use ground check dimensions, and we're going to typecast it to vector3, and that's it. So back in Unity, if you select the player, and if you increase this value, you can see a white line coming up, and if you increase the Y, you can see a box, which is exactly that we want. So I'll set this value to right about here, and the Y is, yeah, it's small enough to check for whether the player is grounded. So if you save and play, I can jump, but I can't double jump unless I'm on the ground, which is cool. Alright, so let's get this movement working as well. In the case of movement, we have an axis and we have a value that we receive from this control type. So in order to deal with values, it's just literally the same thing except we have an argument. So we'll create a function called void, and the name of the function is important. Once again, we'll write on, and then it's going to be horizontal movement, which is the same name as of the action. So it's going to be on followed by horizontal movement, and inside the parentheses we're going to have an argument of type input value. And now this doesn't come up because we need to use Unity engine dot input system to get this particular class. So it's going to be input value. We can call this value whatever we want, or instead we can call this axis because we have an axis, right? So what do we do here? So the thing about using send messages is that it only triggers this action when it is pressed or released, and it does not trigger this action when it is being held down. So we cannot use this like how we use an update function which triggers whenever we hold this particular binding, right? So the way we get around this is we cache this value into a variable. So we'll create a float, we'll call this horizontal input, and what we'll do is we'll set horizontal input equals axis, but axis of type input value, so we need to get the float value out of that input value. Axis dot get, and we're going to specify a float, and this is a generic method which simply returns the value of axis and set this to horizontal input. And now inside update, if I simply say debug.log horizontal input and then play, you can see that it goes 1, -1 or 0 based on the binding that I use. So we found a way to get the current input or the current input value, and what we'll do is simply move the player. So what we'll do is rigid body 2D dot, once again we'll deal with the velocity rather than adding input, and since we're using velocity we don't need to use fixed update. We could work with update because velocity is something that is being recorded every frame rather than on a fixed amount of frames. And we're going to set equals this time rather than adding it. If we add it, it keeps on increasing the speed every frame. So that would be acceleration rather than constant movement. So we're going to need a speed which is going to be serialized field, again float movement speed, and velocity is going to be new vector to horizontal input multiplied by the movement speed. And for the y value it's going to be the same, because if you set this to 0 it's not going to jump. So when we are jumping it's going to set the velocity to 0 for the y, and so it's not going to fall down. So we can't set the y value to 0 because we are using equal to. If we were to add it, then the y, we're adding a value of 0 to the y makes sense. If we're using equals, we can't use 0 because when we're jumping, if we're jumping up, if we set the velocity to 0, it's going to stand still. So it's going to cancel jump whenever we move while jumping. So we don't want that. So instead what we're going to do is simply get rigid body.velocity.y. So we're not going to affect the y, we're just going to affect the x velocity. So if you go back to Unity and then click on the player, and if you set the movement speed to something, let's say 5, you can move. You should use time.delta time because you want to make sure that the speed is constant on. So sometimes if you have a frame rate of 90, you could have a different speed if you're not using time.delta time, because at that particular time.delta time is going to be smaller, so that the overall speed would still remain the same, because at a lower frame rate the value for time.delta time is going to be higher, which means the speed would increase so that everything would not jerk at a variable frame rate. And that's it, I guess. So an important note that this code will not work properly. And it's an honest mistake because I overlooked something, and I'm glad that I'm aware of it right now. The power of editing, right? So using this particular code will not work properly, even though it looks as if it works. This works inside the editor, alright? But if you try to build the game, you'll see something like this. As you may have noticed, the player speed has gone crazy. And the reason why is we're multiplying things with delta time. You should not multiply anything with delta time inside update or fixed update or any type of update if you're working with velocity. If you're moving with transform or something, you should do it. It works inside the editor. That's the thing. But if you try to build the game, you're going to have some trouble. A way to get over that would be to multiply time.delta time or fixed delta time twice. And maybe that would work. I haven't tested it out yet. Maybe you could try it. But there are other two workarounds. One is to actually remove multiplication with time.delta time and instead just use a much smaller value like 10, let's say. And that would work probably. But the better way around it is to actually do something like this. It is to move the code for velocity into fixed update and to remove any multiplication with the delta times whatsoever. So the update looks like this. It contains check for ground which just sets this boolean, not something complicated, but we moved the velocity code into fixed update. And we are not multiplying the x value of this vector2 with time.delta time. Also, there's no point in trying to multiply it with time.delta time. If you set the velocity to, let's say, 10 inside update or fixed update or wherever you want, no matter where it is, the physics engine works only a fixed number of times every second, presumably the fixed update. So no matter where you update the velocity, it's only going to run 50 times per second by default. I believe there's a way to change it inside the Unity editor. So there's no point in using time inside of velocity. You just need to give it a velocity and it's going to move on a fixed frame rate no matter what. It is not dependent on the frame rate of the computer because the movement actually takes place internally inside fixed update. Yeah, it's just going to work. That's it. You don't have to worry about things. You could put this into update as I've mentioned, but in that case you would have to remove time.delta time and see if it works. I haven't tested it myself. Also, just simply make sure to perform test builds from time to time so that you won't fall into such errors. So to finalize, just go with what I have here. You could use update for check for ground function and you can use fixed update to update the velocity. Also, quick tip, you shouldn't use velocity inside update if you have some sort of acceleration. Let me elaborate. So right now we have movement speed, which is a float. So if this value is something that can be changed or that is being changed constantly, or this value gradually increases or decreases, then you shouldn't use it inside update because sometimes in faster machines update happens a lot more frequently than fixed update, and it's going to accelerate inside update and not fixed update. So it's going to skip some values of acceleration, and if you have a higher frame rate PC, it's going to accelerate for a long time unless you decide to clamp it. And even if you decide to clamp it, it is going to clamp early in a faster machine compared to a slower machine. So if you have some sort of acceleration for your movement, it's better to use fixed update because the acceleration for this value also comes into effect inside fixed update. So yeah, now back to the video.
Also subscribe.
We can also go back to the jump and then add a binding. Let's say I'm going to say W for the jump, and if I save it, and it would still work if I press W then the space bar, and it will also work if I press space bar as well. So things are actually smooth and we have a working player controller. Sweet. So that's it for this video. I hope this was useful to you. If you have any questions or if you want to say something, if you think that I've made a mistake or if you think that I'm an idiot, please do mention it in the comments below. And if you have any suggestion on what video should I make next, please do let me know as well. And yeah, please do hit the like button so that it helps YouTube recommend this video to other people in need. And also subscribe if you want to see more of my content. So yeah, that's it. Take care. Bye bye.